Good day, everyone. Yeah, welcome to another segment of online iPost tutor. Today we are going to be looking at continuity and differentiability in MTH 281 under mathematical method 1. Now let's look at continuity of a function. What is the basic idea behind continuity of a function? Now let's explain this graphically. Let's say a function A moving from a point to another function B. Now we regard this function as continuity. How is it continuous from point A to point B? The reason is that there is no any breaks between the point A interval to a point B. That means that we regard this function as a continuity of a function. Now, let's look at another graph that discusses a discontinuous of a function. Let's say you have a point A moving to another point here moving to another point. Let's regard this one to be a point A, here to be point C, and here to be a point B. Now, this function is discontinuous. Why is it discontinuous? Because there is a break. There is no any connection between this point and the other point. Meaning that it is what? A discontinuous function. Discontinuous function from A to B. Now let's look at another function that discusses a discontinuous function. Now we refer this as a positive infinity and here to be a negative infinity. We regard this as an infinite discontinuous. Now let's say you have a function f of x equals 1 divided by x minus 2. We regard this one as a rational function. Now here, our function here will be x does not equal to 2. Why? Because this one will be an function, this particular function here is undefined. Why is it undefined? Because here will be equals to 0. And once it's equal to 0, that means that x now will not be equal to 2. That means that we regard this as what? As an infinite function. And also it is being referred to as what? A discontinuous function. What is the main idea behind differentiability of a function? Continuous function f of x is continuous at some points. And the first derivatives of f of x is the derivatives if it's continuous or not. Now, the differentiability describes the continuity of the first derivative function. That means that there is at some point a function may be continuous and not differentiable. And at some point it might be discontinuous and not differentiable, or differentiable at some point, depending on how the function is being given, that describe the continuity or differentiability of a function. Let's look at this example of a function. Now, f of x equals x squared as x tends less than 0, and x plus 2 as x tends greater than or equals to 0. Now, is this function continuous at x equals 0 or differentiable at x equals 0? Now, what you need to do is the continuity of a function of these two functions must equal to each other. The continuity of a function from left and right side must equal to each other, because that one will determine the continuity of a function. Once they are not equal to each other, that means that they are what? They are discontinuous. Now let's start. Now this one will be limit as x tends to 0 of x squared equals, this one will now be 0 squared. That means that you are substituting the value of x here. That means that let's represent this one as a left side. That is limit of 0 at the negative side. That is that we are having a left side and the right side. Now that means that this one is 0 square equals what? Equals 0. Let's look at the right side. Limit as x tends to 0, as the right side, we have x plus 2 equals, now the value of our x is what? Is 0. Is 0 plus 2. Is 0 plus 2 is what? That is 0 plus 2 is 2. That means that the left and right side are what? The values are not what? Equal. That means that limit as x tends to 0 from both sides equals what? That means that they are what? They are what? Not, say, does not exist. Does not exist. Just because the value of the left and right side are what? Are not the same. And once you have a discontinuous function, automatically the differentiable part also be what? Will be not differentiable, because continuity at times determine the differentiability of a function. Second example, we're having function of x squared minus 3 as x tends less than 2, and the second function is 4x minus 7 as x tends greater than or equals to 2. Now, to find this particular function, we are going to look at it from left and right. As you all know that this one is limit as x tends to 2 from left side. We use negative to represent left side and positive to represent the right side. This one now this one gives us x squared minus 3. That means that we are substituting the value of x to be what? To be 2. This one now will now give us 2 squared minus 3. 2 squared is what? 4 minus 3 equals what? Equals 1. Let's look at it from the right side. Limit as x tends to 2, we have 4x from right side, that's positive, from right side 4x minus 7. Let's substitute the value 4 into 2 minus 7. This one will be 4 times 2, that's 8 minus 7 equals 1. Now if you look at this function, they are what? They are continuous, because the values of the right and left function are what? Are equal to each other. Now let's move on. Since we are having 4x limit as x tends to 2 from function of x equals, you have 4x minus 7, x greater than or not equals to and x greater than and equals to 2. That means that this one equals what? Equals 2. That means that we are substituting the value of x here to be what? 2. This one also will be what? 4 into 2 minus 7. 4 times 2, that's 8 minus 7 equals 1. Now this three method now determine the continuity of this particular function. Now let's look at the differentiability. Now that means that the value of what we have here needs to be what? To be differential. We have to find the first derivative of the function. Now this one now will now be, since we are having function of x, that is the first derivative, equals, when you differentiate x will give us 2x, and when you differentiate 3 give us what? Is 0, as x tends to less than 2. Now if you differentiate 4x give us 4, as x greater than or equals to what? Equals to 2. Now from here, that means that we need to find both sides. X tends to 2 at the left side. This one is 2x equals, now 2 multiplied by 2 equals what? Equals 4. Now let's look at it from the other side. Limit as x tends to 2 from the right side. That means that this one equals what? This one doesn't have x. That means that we have 4. That means that it's differentiable at what? At both sides. That means that this one determines the differentiability and the continuity of a function.